on these physical quantities as well, distance, displacement, speed, velocity, acceleration, right? And we've also covered all these three types of graphs, acceleration time, velocity time, and displacement time graphs. Um, Now, let's try to understand this concept of I mean areas भी हमने कुछ हद तक किए हैं. Let's try to look at the displacement time graphs in detail, and how you can sort of derive the equations of kinematics from these graphs. Okay, so all of these equations are basically called uniform acceleration equations. ठीक है? Uniform acceleration equations are basically when you apply these concepts of kinematics, by understanding that these equations, the object is sort of moving under uniform acceleration. Okay, अगर एक falling object है, it would be falling under the influence of gravity, and because gravity has a constant value of 9.8 meter per second square, so that value is also uniform, and it also acts as the acceleration for that object. Okay, so the area underneath the velocity time graph is displacement. This is a velocity time graph, and the area underneath this graph is the displacement. अब इसमें आप you apply the area formulas. आप ये देखते हैं आपको ज्योमेट्री कितनी आ रही है यहाँ पे. अगर there's a triangle, there's a rectangle, so you add basically you add the areas of triangle and rectangle separately. For example, what is area of rectangle? It is length into width, right? So length in this case is the value of t on the graph, and the value of u over here is the width of this rectangle. So this is u times t, because u is the initial velocity till this point, right? And d is
Right.
this entire length. Then area of triangle. Area of triangle is half base into height. Half base is u, height is v. So u, v, but because there are like two values, so it's like v into t by 2 minus u into t by 2. Why? Because we're sort of getting a difference of this value over here. It is half base into height, but when you look at the height over here, yeah, sorry, this is the height, v and u. So what you're doing here is where you're doing a v minus u upon sorry, minus u into t. Okay, again, this is, let's say, base, so you multiply t. नाउ जब 1/2 यहाँ अप्लाई हुआ है, तो 1/2 पहले तो t ओपन अप हुआ विद वी टी माइनस यू टी, और फिर 1/2 भी, because it was underneath both of these, so we opened up separately, vt over 2 minus ut upon 2. Got it?
Okay.
So this is how we got this form over here. So it's important to understand that this is how the area of triangle is expanded. And then once you solve it further, because you आपने इसका LCM लिया इन सबका, तो आपको the form that you have was ut over 2 plus vt upon 2. ये पूरा LCM के बाद solve हुआ है. Okay. अच्छा, now okay, so why did we do all of this? आपने u, because 2 is the denominator, so you've just categorized it. You just wrote it once between underneath u, u plus v, और t को आपने फिर कॉमन लेके साइड पे कर दिया. तो ये क्या है? दिस इज एन इक्वेशन फॉर डिस्प्लेसमेंट. ठीक है, तो यहां तक वी हैड
ठीक
टू
है.
अराइव एट दिस इक्वेशन. आपने नोट इवन आस्क्ड यू टू derive this equation. I mean, MCQs में you can expect such a question, but generally in theory nobody's gonna ask you for this derivation. But you should know, because ये पता होना चाहिए कि if you're using a particular equation, how did we arrive at that equation? You should be aware of all of this. Okay, next up, the gradient of a velocity time graph is the acceleration. तो हमें पता है कि अब if this is a velocity time graph and the gradient of this graph is acceleration, so acceleration का formula is v minus u upon t. So if you rearrange it, again making v the subject of the formula, this is another equation that you have. v is equal to u plus at. u plus at यानी आपने इसको rearrange किया, a के साथ t multiply हुआ, u को दूसरी साइड पे ले गए, v इधर रह गया, तो it says u plus at. Okay, so this is the second equation of motion that we have. Okay, next up, the area beneath the velocity time graph is displacement. Therefore, अच्छा ये वही equation है जो यहाँ से है, the same concept. We're using this particular equation, area of rectangle plus triangle, और उसको what we're doing here is, instead of v minus u, we're writing at, because v minus u, you see on this side, is equal to AT, right? अगर हम इस t को, if we multiply t on this side and we write it as AT is equal to V minus U. So what's happening over here is that essentially V minus U is also equal to AT, right? So instead of this entire thing, V minus U, we're just writing AT because ये equal है. And the rest of the equation is saying UT plus half AT. This t is going to
ठीक है.
multiply with this time here, and it's going to become UT plus half AT square. So this is another equation of kinematics, the third equation. ठीक है, ये हमें यहाँ मिल गई. अच्छा, अब the last equation, what you can do here is in the last equation, you can substitute the equation from part 2 into the equation from part 1. यानी this equation, ये वाली जो है, into the first equation जो हमने पहले देखी थी. Okay, let's look at that again. तो ये थी, this was your first equation. U plus V by 2 times T, V 0 U plus AT. Let's pick up these equations. V 0 U plus AT, you rearrange it, you make time the subject of this formula. ठीक है, आपने जब time को subject बनाया, you have V minus U upon A on this side. अब V minus U upon A, let's try to bring in S over here. S क्या चीज है? U plus V by 2 into T, right? This was the first equation. So instead of using time over here, what we're doing is we're writing V minus U over A. पूरा time इसको T को हटा के we're using this thing over here. So this was basically T. ठीक है, हमने T को यहाँ से remove कर दिया और उसकी जगह what we've written is V minus U upon A. And on this side, what you have is U plus P by 2 as it is, जो ये वाली चीज है. And now once you multiply U with U, V with V, 2 with A, S is equal to U V square minus U square over 2A. इसको इधर ले गए तो इक्वेशन रीअरेंज होके बन गई V square is equal to U square plus 2AS. This is another equation, fourth equation. Is this
ठीक है.
clear?
Okay. Yes.
Okay. So basically यहाँ पे you, this is the first equation, V is equal to U plus AT again. Second equation is S equals U plus V by 2 into T. Third equation is UT plus half AT square, and V square is equal to U square plus 2AS. Where everywhere in this equation, S is equal to displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time. This is what all of these quantities represent in in these equations. Got it?
Okay. How do you know okay, when you should use which equation?
Yes. Now that's the next step. You will have to do to होता ही है कि once you have a question, you'll have to very wisely choose between these four equations. And one way of doing that is you write down the quantities that are given in the question. For example, if they've given you value for V, if they've given you value for S, A, you'll know if let's say you have, sorry, if you have like three values already given in the question, you'll know the next one, the unknown that you need to find. उससे फिर you pick up the appropriate equation. इसमें प्रैक्टिस करनी पड़ेगी थोड़ी सी, हमें तब पता लगेगा. We'll do a lot of questions related to these equations, then you'll know when to pick up which equation. Okay, let's look at these examples here. Okay, just when approaching questions which require the use of these formulas, it is useful to write out the values you know, the ones you want to find out in order to more easily choose the correct formula used. This is very important that you write out whatever is given in the question as the as the data that's there. Then you write down all the unknown values and then you pick up the correct formula. Okay, for example, stone is dropped from a bridge 50 meters above the water below. अब we're looking at this now. ठीक है, ये कहाँ तक जा रहा है, यहीं तक जा रहा है. अच्छा, ये आगे भी है. अच्छा, anyways, a stone is dropped from a bridge 50 meters above the water below. What will be its final velocity, V, and for how long does it fall, E? So, first of all, note down the data that you have and note down what you need to find. Stone is dropped from a bridge 50 meters above. So, ये तो हो गया displacement, right? So, you just write down that you know the displacement. which is 50 meters. Okay. Then U, which is the initial velocity. If stone is dropped, देखो सबसे बेस्ट चीज होती है, you always visualize it, draw करो साथ साथ कि ये let's say this is the bridge और यहाँ से you're dropping a stone downwards. So if you're sorry, if you're dropping it from the side over here, तो इसका मतलब ये है कि okay, this is way too. यहाँ पे जो इसकी initial velocity है, it is zero. Why? Because अभी तो आप you're holding the stone, right? Then when it
Yes.
moves, यहाँ पे just before touching the ground, it will have its final velocity v, which you're not aware of, and you're supposed to find that. And then time t is the time that the stone will take to fall. S is the displacement that it will cover from top of the bridge to the bottom. So U is zero, V is question mark, A is 9.81. So now you see we've kept acceleration as the acceleration of free fall. Why? Why did we assume that the acceleration over here is 9.81? The reason for that is there is no force that is causing the stone to move down. Whenever there's no other force that acts on a stone, you can very safely assume that the acceleration will be equal to 9.81. Why? Because it is basically the value of gravity, and it indicates that the object is falling under the influence of gravity only. Hence, it's free fall motion. Free fall motion में यही होता है कि the object falls solely under the influence of gravity and not in under any other influences. So this is why you can assume that 9.81 meter per second square is the acceleration. Okay?
Okay.
अभी समझ आई है ना बात?
Yes. Exactly.
Okay. And t is equal to time which is question mark again. अब ये दो अननोन क्वांटिटीज हैं. अब तो हम देखते हैं कि इक्वेशन कौन सी चूज करनी है. देखो पहले तो बात है ऐसी इक्वेशन पे नहीं जाना चाहिए जहाँ t और v दोनों आ रहे हो, क्योंकि दो अननोन्स हो जाएंगे. तो लेट्स गो फॉर एन इक्वेशन दैट ओनली हैज v अननोन, a हो उसमें गिवन u और v हो. तो ये इक्वेशन आती है v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2as, जहाँ पे यू हैव द वैल्यू ऑफ एक्सेलरेशन, यू नो s, यू नो u. तो ये सब डालेंगे तो हमें v तो मिल जाएगा आसानी से, राइट? So this is how we picked up the appropriate equation once we knew the data that we have and the data that we're supposed to find. V square equals u square. U square is 0 square plus 2a acceleration s 50 डाला किया हमें मिल गया यहाँ पे velocity 31.3 meter per second. Now this is the final velocity of the stone. Stone की initial velocity 0 थी और वो 31 पे final में जाके touch हुआ. अब now you also know another quantity which is v 31.3. We just need to find t. For t, we'll see catch. Now, once we know v, a, u, s, so now you've got a lot of options to use from. Ut plus half at square use करते हैं. अच्छा, अब ये एक और, this is something that you can note over here, that this equation ut plus half at square is generally used whenever the questions talk about falling objects. आपको ये चीज खुद देखने को मिलेगी जब भी falling objects questions आएंगे, this equation will really help you. Because this equation doesn't need anything at all. U अक्सर zero होता है falling में. Acceleration 9.81 होती है. It's just S and T. So this is why this equation is really helpful for falling objects. Okay. So U is again 0, T is unknown, S is 50. हमने सब कुछ plug in किया है. Acceleration 9.81, T again unknown. तो ये कर करा के हमें आप बेसिक मैथ्स और आपको टी की वैल्यू मिल जाएगी 3.19 सेकेंड्स. ठीक है, गॉट इट?
ठीक है.
Okay, now this particular thing would really help you understand how um to figure out acceleration due to gravity. अगर तो for example, if you don't know what the acceleration is, but you do know that the object is falling under the influence of gravity, so you can find out the exact value of g over here, exact value of acceleration through this experiment. And this may help you in a practical setup as well, or in the planning analysis evaluation paper that you take in A2. This kind of questions are there on that paper. So what you do is you set up an apparatus as shown in the diagram, connecting the light gates to a data logger and as close to the electromagnet as possible. अब electromagnet हम क्यों use कर रहे हैं? ताकि जो stone है, जो metal ball है, it sort of sticks to the electromagnet. The electromagnet is connected to power supply. It's gonna keep um, the stone. Sorry, because of magnetization, it's gonna keep the stone or the ball, metallic ball, attached over here. Okay. Light gates क्या होते हैं? Whenever, as soon as you turn off the electromagnet, this ball is gonna drop. As it passes the first light gate is gonna tick, and the clock will start. When it covers the distance of h and it passes the second light gate over here, it's going to tick again and the clock's going to stop. This is an automatic electronic stopwatch that we're talking about. Okay? In this case, once you know a value of h, which is in this case 0.75 meters, you can simply apply the formula because आपको पता होगा time, you'll know height, which is going to be the displacement, right? Once you know displacement, you know the time, you can apply the formula for acceleration. Yes?
Yes, ठीक है.
ठीक है ना? So the position of the lower light gate should be adjusted such that the height h is 0.75 meters, measured using the meter rule. Turn on the electromagnet and attach the ball bearing. Switch off the electromagnet and note the time taken for the ball bearing to fall between the light gates E as recorded by data logger. यहाँ से आपको time मिल गया. Reduce h by 0.05 meters by moving the lower light gate upwards and repeat the above two steps, reducing h by 0.05 meters each time down to 0.25 meters. आहिस्ता आहिस्ता height कम करते जा रहे हैं. Repeat the experiment twice more to find the mean values of t for each value. Why are we changing the values of height? Because we need to find out a mean value. हम क्योंकि average पे जाना चाह रहे हैं. And this is not going to affect the experiment in any way because once you reduce the values of time, you're definitely reducing the height as well. So height and time are because they're directly proportional. So the values are sort of changing together and it doesn't affect the accuracy of your results. Instead, it's going to give you an average value, which will help you determine the accuracy and it will help you get a more accurate result at the end. You can use this equation ut plus half ad square because you're going to know the time. You're going to know s, u is 0. आपको acceleration मिल जाएगी. It should be equal to 9.81 meter per second square. Got it?
ठीक है.
यहाँ पे this is basically projectile motion, which we're gonna keep for the next class. So, any question from today's lecture?
नहीं.